Today, we're going to talk about tables, graphs, and the equation of the line. And before we begin, I'd like you to think about what is a function in mathematics, and can you name this particular function below? Well, a function is something in math where you have for every one input, you have a corresponding output. It's a one-to-one relationship. And some of you have actually done this before. You've used what's called the vertical line test to tell us if we have a function or not. So if I were to take the line and go straight up and use a vertical line for all of these points, for every one input that I get a corresponding output. And that's what we're going to define as a function. We're not going to use this definition so much in this class. We just have to have a basic understanding of what it really is. Okay. As far as the name of this relationship, I'm going to give you that in a little bit. Okay. But before we get to that, let's talk about what we're going to do here. Today we're going to learn the proper way to display data in tables and graphs. Then we're going to identify the different types of relationships between the two variables. And then we're going to write an equation of a line that relates the two variables. All right, so let's start with data tables and graphs. First of all, the title of your data table and graphs must be displayed when you write them. All right, an example of the title would be, I'm going to use a generic word here, but I'll use it later on. The dependent variable, whatever that may be, the name of that, versus the independent variable, whatever the name of that's going to be. The second thing is we want the independent variable is always going to be first in the data table. It's going to be in the first column, and it's going to be on the horizontal axis of the graph. For the dependent variable or multiple dependent variables, they're always going to follow the independent variable in the data tables, and it's on the vertical axis of the graph. And the variables and units are always going to be displayed at the top of the table. Keeping in mind, though, that our units are going to be in parentheses. So let me show you here. So I've got my data table here, and at the top, I've got my variable and my unit in parentheses. My first column is going to be my independent variable. My second column is my dependent variable. And take a look. I've taken this information and I've placed it right down here because this is my independent variable with my units, and this here is my dependent variable, my variable and its units. Now the title, like I said, it's going to be the dependent variable versus the independent variable. It's not necessary to put the units up here in parentheses, but you can, and I won't take off for it. And it's not wrong. It's just sometimes you just write the name of the variable versus the name of the variable and just omit the units. Okay, so there's going to be some relationships with variables that we have to know in this class. We just have to know them. There's 5 of them. Okay, the first one is going to be what's called a no relationship. When we graph our data and there's a straight line that goes straight across and it's horizontal, there is no relationship between the variables. The second one is going to be what's called an inverse relationship. As one goes up, the other one goes down. They're inversely related. The next relationship is going to be what's called a linear one, and this is the one that's most commonly used that we can use in this class, and the one that we commonly find in our data collection, but it's not the only one. The fourth one is going to be a squared relationship, where the x variable is going to end up being squared proportionally to the y. And then the last one is going to be that square root relationship, which is the one I showed you in the warm-up. I wonder if you guessed it. If so, good job. If not, that's okay. But you do need to memorize these, okay? So eventually you're going to be held accountable for this information. So I would get this information in our brain as soon as possible. Okay, so we've got a graph here, and from here I've collected some data, and it looks like we got a straight line here. So we're going to go ahead and try to calculate the equation of this line. Okay, well, in math we've seen it several times before, where we're going to take this data and draw a best fit line. This is called the best fit line, and basically it's a line that fits most of the data, or at least half of the data on one side and half on the other. Next, we're going to take and use what's called the slope-intercept equation in the form of y equals mx plus b to generate our equation here, where our y is going to be the y variable here, and our slope, m, is going to be the slope of this red line. Our x is the x variable down here. And finally, the plus b is where this line intercepts the y. This is called the y-intercept. To calculate the slope, we all know it's rise over run. But what it really means is that we're taking the y2 minus the y1 over the x2 minus x1. And that's really what we do when we calculate the slope here. So, to do so, we're going to pick two convenient points on the line, not the data points. Okay, so once you draw a best fit line, you essentially ignore the data points. We don't care about them anymore. The only reason why we use them is to generate our line. So there's a data point there, there's a data point there. Don't care about them anymore because all we really want to know is what's the best fit line for this data. So let's pick 2 points on the line, not the data points. Well, it's convenient to pick any kind of line that's crossing the gray crosshairs here, or a vertical and x-axes here. So this point right here, it goes right through our vertical and our horizontal gray lines here, and so does this one. This one over here would not be as good of a line to pick because it does go through the vertical line here, but it goes somewhere above the 25 here, so we really don't know that number so much. So we want to pick something that's a little bit easier to identify real quick. So we've got our 2 points here. Then we just simply plug in the numbers. Okay, so we've got, for our rise, we've got 15 centimeters minus 10 here and here. And then for our run, we've got 4 minus 2 here. And then when it's all said, we get a slope of about 0.4 centimeters per 1 day. Okay, so then what we're doing here is we've got a mathematical equation. Well, this is not a math class. Physics is an application of math, so we're never going to really use x and y. Instead, we're going to use the variables that we measure in experiment. Okay, so let's go ahead and turn this equation into a mathematical model here. And here's what we do. We've got our y variable. Well, in place of my y variable, I'm just using this information here, height in centimeters. For the slope, here, I'm going to calculate the slope, but remember our slope has units as well. Rise over run. So I'm going to use my rise units, which are in centimeters, and our run units, which are in days. And so that's the slope, and that's the units for our slope. For my x variable, I've got time in centimeters. Oops, that's a typo. That should be in days, so I'm going to change that later. And then finally, our plus b is going to end up being in centimeters because that's the unit for my y intercept here. Okay, so you give it a shot. What I'm going to encourage you to do is to pause the video and try to come up with a mathematical equation that represents this line. Go ahead and pause it. Okay, did you get this one? Where we've got the height in meters is equal to 2 meters per second, or 2 meters for 1 second, times minus 3 meters. Okay, so did we in this video learn the proper way to display data in tables and graphs? Yes, we did. Did we identify the different types of relationships between the two variables? Yes, there are 5 of them that you need to know. And then finally, did we write an equation of a line that relates the two variables? And yes, we did. And remember, this here is what we call a mathematical model. It's the model of the data that you collected in experiment. Okay? Thank you.